So in this video, we're going to talk about the idea of union and intersection of sets, and then we're also going to get into compound inequalities, in particular how union and intersection will translate in terms of the words and or, in terms of and or. So we're going to connect unions and intersections with the words and or. All right, so first, what's a union? Union gets denoted of two sets with what kind of just looks like a U without the tail. And what it means then is we are looking, it's the set of all numbers that are in either set, in either A or B. So we're looking for all the numbers that are in either set. So what I often encourage people to think about on this one is to think about when you think of the word union. Union is sometimes a word that gets used for a marriage as a union between two people. And so if you think of it that way, think about two people. Let's go back in time when people didn't live together, typically before they got married. I'm going somewhere with this. So let's pretend that you had two people, person A, person B. They lived separate, and then they formed their union, their marriage. And so what happens with all their stuff? All the stuff that person A had and all the stuff that person B had, we take all of it together and we put it all in our new place together, right? We take all of it. So when you think about a union or a marriage, I want you to think about taking all of it. You take all of the stuff. Now, if you each have a toaster, you typically get rid of one of them, right? So I'm going somewhere with this. You take all your stuff and you put it together. But if you have duplicates, you don't keep two of them. Meaning, as you're writing numbers of a set, if it's in both sets, you only write it once. You don't write 3, 3 if 3 is in both sets. So here's what we're looking at. So a couple of things that we're starting to connect here also. So union symbol, it's synonymous with the word or. So it's everything that's in either the first set, you can think either or, either the first set or the second set, and we want to think to ourselves, this is when we take all of it. All right, now let's go on to intersection. Okay, so intersection gets denoted with an upside down union symbol, and this is going to be the set of all numbers that are in both set A and set B. So now I want you to think about intersection, the symbol, and it's synonymous with all of the numbers that are in both the first and the second. So intersection will be synonymous with and. So when you think about intersection, I want you to think about, like, the most common way that we use intersection is the intersection of two streets, let's say. And if you're standing in the middle of an intersection, this implies that you're in the overlap of both streets. Like at that moment, you're literally on both streets at the same time if you're in the intersection. So I want you to think about intersection as the overlap. So intersection and the overlap, union or take all of it. All right, let's give it a whirl here. Let's look at an example just using this idea. So suppose I have a set, and I'm going to use this as a chance to kind of just show you some different type of notation just for the heck of it. So suppose I have the set of all x such that, and I'm going to make a new symbol you probably haven't seen. It kind of looks like a C with a little line in it. And this little symbol, you're probably not going to see it in your homework. I'm just introducing you to a new type of, potentially new type of notation. This gets read is an element of. Means it's like going to be in this next set that I'm going to denote. So it's an element of, or it's in the set of, and I have a big W there. And that big W is going to represent for us that set of whole numbers. And we'll talk about what that set was. We'll review that in just a second. So it is the set of all numbers such that x is an element of the whole numbers. So x is a whole number. And the other criteria is that x needs to be less than or equal to 5. So that's set A. And then let's have set B equal just a simple roster form, -1, comma, 0, comma, 1. So real short there. Okay, so the first thing I want us to realize here is what set A looks like. And set A, so remember the whole numbers, often students remember those as they think the whole and the O in whole, it starts at 0, and then it's 0, 1, 2, 3, and so on. So if we were going to write this out instead of being in this kind of notation that it's in, let's think about what this means. Set A then starts at 0, 1, 2, and then I need to make sure I satisfy the second criteria, which says that x needs to be less than or equal to 5. So I have to stop my listing here. So right now I'm just listing out all the whole numbers, but I also need to satisfy x needs to be less than or equal to 5. So I stop there at 5. So there's set A, and now set B, just a listing in roster form. Now I have them both in a roster form. All right, so number 1, or the first part here, let's write out the union of these two sets. So remember, with union, so as we're looking at union, that means, look back up at the top here, I'm extra highlighting, take all of it. So union is a marriage, you take everybody's stuff and put it together and throw out duplicates. So as you're writing out everything, you're just taking everything in the first and everything in the second, but don't list a number twice. So as we write this out, in order, -1, 0, 1, 2, 3, 4, 5. So all of the numbers, that's the union. All right, the intersection then, the other one. So let's do the intersection. So A intersect B. So the intersection, we want to think to ourselves, intersection is the overlap. So what's in both? These can also be shown with Venn diagrams if you've seen those before. I'm not taking the time to do that here, but that's a nice visual. If you've ever seen those before, you could use that here. But here I'm looking for all the numbers that are in both sets, and I've just highlighted them in green there. And it looks like we just have the two numbers 0, comma 1. So those are the two numbers in my intersection. All right, so with that said, let's, in essence, what I'm going to start here talking about compound inequalities. Oh, it looks like my line got moved down. I needed to backspace there. But we are going to, now we're going to take a look at, I'm just going to add my, I meant to just have this line up here. All right, so now we are going to define, sorry about that. We're going to define the and or, but honestly we've just done that up above. But as we get going and we see compound inequalities here, compound inequalities are going to be using the words and or when they write out the problems for us. So when we see and, again, going back from up above here, so and is the same thing as the intersection. So after we get done solving potentially two different inequalities, when we get done, we want to look for our final answer. The solutions are going to be, again, all the numbers that are in both. All the numbers that are in both. I think that's okay. And that is synonymous with, we could say that is like the overlap. Right, so we're looking for everything that is in both the first set and the second set. And so that is going to be like looking at your overlap. So a little bit of repetition here. I apologize here, but just driving the point home. All right, so then or is going to be the synonymous union idea that we've talked about. So or is going to be synonymous with union. And so in this situation, we are going to be looking for, when we're done, we'll be solving a couple of different inequalities. And when we're done, we're going to take all the numbers that are in either set. And so when we say we're taking all the numbers that are going to be in either set, actually let me add that word sets, I think even up here, up above. So we're looking for, I'm going to go back here, and maybe you can just insert the word. So we're looking for all the numbers that are in, for the intersection up here, in both sets. And again, that will be the same thing as looking for the overlap. Okay, back to the or. So the or is going to be looking for all of the numbers that are in either set. And that really then is the same thing as how I've been saying we take all of it. All of it gets included. All right, so just a little bit of repeat there, a little bit of repetition. Let's take a look at an example, and then we will do probably just one example here to end this video, and then we'll come back and look at a couple more next time. So we're going to solve and graph, and ultimately we want to write our final answers in interval notation. So we're going to do one part A. And suppose I'm going to start really simple with the inequalities. And so remember, when you solve linear inequalities, everything is the same as with solving equations, except, and we're going to review this right away, if you multiply or divide by a negative, you have to reverse the direction of the inequality. Otherwise, the solving is the same, and you should have seen that like in a basic algebra course. All right. So we're going to solve each of them. So I solve the first one, and I'm going to add 5 to both sides. And so my first inequality here, as I solve that, is simply going to be that x is less than 4. And that's the compound inequality word I'll have to pay a lot of attention to. On the second one, and here it is right here, it's this action of dividing by a negative. It doesn't actually matter what the final result is, like the number that we get. That has nothing to do with it. It's the action of dividing by the negative that makes us reverse the direction of our inequality. So in this one, we end up with x now is greater than, and 20 divided by negative 5, of course, is negative 4. So that's the only thing you have to remember in terms of your mechanics of if you divide by a negative, reverse your inequality. All right, now here's going to be, as we look at kind of coming up with our graph here. So this is going to be what I'm going to call our work graph. It's not going to necessarily be my final graph. It's going to just honestly be looking at each of these and thinking about what this would look like graphically here. All right, so let's say this first one, it's everything x is less than 4. So let's say we have 4 over here, so there's 4 right here. X being less than 4 is everything smaller than. The solutions are on the smaller than side of 4. So everything less than 4 here. Now I'd have to be real clear and say 4 is not included, either with an open circle or an open parenthesis curving in. Now, the second solution that I'm looking at there is x is greater than negative 4. Okay, so let's say we have, maybe negative 4 over here. So let's say that's negative 4. These are all the numbers that are greater than, so on the larger side of 4. So these are all of the numbers going from negative 4, excuse me, I think I just said 4 there. So these are all the numbers going from negative 4 off to the right. So what we want to look for here is everything that, oh, and let's be more clear, at that point, negative 4 is also not included, so an open parenthesis there. So we need to be really mindful now of what the word and implies. So and implies, look up above, and implies overlap. So and should make us think overlap. It's the part that gets shaded twice. That's what we're thinking about. And here it was everything in between the negative 4 and 4. So our final answer, that was just the work. That's just kind of graphing them both on the same number line, which is good to do. That's how we determine what our final answer is going to be. So I'll just say the final answer here. So our final answer for our graph, and then we'll put it in interval notation, is going to be this overlap. It was everything in between the negative 4 and the 4. Again, either with your parentheses like that, or you could also certainly use the open circles there. That is our final solution for the graph. And then the interval notation kind of follows just real nicely from there, everything between negative 4 and 4. So that's the final graph and the final interval notation. All right, so let's think about a part B while we're on the same one, and then I will end this video here. Suppose we had the exact same problem, but the only difference was we had the word or. So again, we were looking, I'll recopy, but it's just because I'm going to kind of be off my window up there. So let's say I had the exact same original problem. And so you know what? Everything up until the final answer would have been exactly the same thing in terms of doing our work. We would solve each of these for x. We would have x is less than 4, in this case, or x is less than negative 4. And we would still have the same work in terms of our graph and thinking about what our solution would look like. So the first part of the graph here would have been everything, what did I say, less than 4. I think I put 4 here, and then shaded everything less than 4. So I'm going through this quickly because we did this one already. But that was everything that was less than 4. And then we did everything that was greater than negative 4. So we put like negative 4 over here. And then we did everything that was greater than negative 4. And then that part looked like this. Okay, now everything, notice about that, was exactly the same up until we're going to now think about what our final answer is going to look like. So this is how you're going to solve these. You're going to look at each of them, solve them both, put both graphs on the same number line, and then you're going to think about, well, what does the word mean that I'm looking at? So if I'm looking at and, I'm thinking overlap. If I'm looking at or, I'm thinking about taking all of it. So with or, it's synonymous with the union, and that's where we take all of it. Well, in this case, all of it, anything that was ever a solution on either the first or the second, everything got shaded at least once. Some things got shaded twice, but everything here got shaded at least once. So on this one, if we were to think of our final answer, our final answer would simply be, I wouldn't even need to plot the -4 and 4 at this point. My full solution is simply graphing the entire number line. So if you're graphing these, like let's say on your homework, you don't need to nor want to, you might not even get full credit. If the computer senses you graphing the first one and the second one, it may not give you full credit because that's it sensing that you're just graphing them both together. It's just the whole thing, just one big shade and you would be done. Now, in interval notation then, this has a nice interval notation, and it's everything from -infinity to infinity. So that's what our final answer would look like as a graph and as the interval notation. So the moral of this first story, in this first example, is obviously the importance of the word that is either and or. All right, we'll do another example or so next time.